So in this video, we are going to talk about caustic corrosion. First of all, we'll have to understand what is a caustic. Caustic is an alkaline solution generally used to treat boiler waters, and this kind of corrosion will generally have an appearance where you can see a localized metal loss or a pitted area which is generally going to be filled with the corrosion products. So localized description of damage: localized corrosion due to concentration of caustic or alkaline solution such as NaOH and KOH, that is sodium hydroxide and potassium hydroxide, and or corrosive salts from those solutions that usually occur under evaporative or high heat transfer conditions, commonly known as caustic gouging. Also, the corrosion resulting in general thinning can occur at elevated temperatures depending on the alkali or caustic solution strength. Affected materials: primarily carbon steel, low alloy steel, 400 series of stainless steel are susceptible. Carbon steel is the material most commonly used in situations where caustic corrosion is of concern. 300 series SS is generally resistant to caustic type of corrosion until passively damaged. So if your 300 series is damaged, then this can happen, but if you have good condition of 300 series SS, then this is generally not prevalent, which can occur at the temperature ranges of 70 degrees Celsius to 100 degrees Celsius or 160 degrees Fahrenheit to 210 degrees Fahrenheit, depending on the concentration of the caustic solution. 300 series SS can also be susceptible to caustic stress corrosion cracking at elevated temperatures. Critical factors: caustic, that is potassium hydroxide or sodium hydroxide, must be present. Following are the sources of caustic. Caustic is commonly added to treat boiler feed water and may also inadvertently enter during regeneration of demineralizers. Caustic is sometimes added to process steam for acid neutralization or to react to remove sulfur or chlorides. Alkaline salts may also enter the process stream through leaks in the condenser or other equipments. Concentrated caustic is handled in the storage feed equipment used for feeding the caustic into boiler feed water or process steams. In high solution strength caustics, the temperature above 75 degrees Celsius with temperature limit depending on the caustic concentration will cause general corrosion of the carbon steel. For localized caustic gouging to occur, the concentration mechanism must exist to build up the caustic strength or salt solution. Caustic can become concentrated by departing nucleate boiling, evaporation, deposition of salts. Higher temperatures to help produce a concentration mechanism, thereby increasing the corrosivity of the solution while also generally increasing the corrosion rate. Affected equipments: localized caustic corrosion or caustic gouging is most often associated with boilers, steam generating equipment including heat exchangers. This also applies to steam generating equipment in hydrogen manufacturing units and steam generators within other process units. Similar concentration effects of caustics can cause caustic where the caustic is added to the crude unit feed. Accelerated localized corrosion can occur in preheat exchangers, surface furnace tubes, transfer lines if caustic is not effectively mixed in the oil stream. Heat trace tanks caused for caustic storage, caustic feed equipment near the process injection location can suffer caustic corrosion if the temperature is too high. Appearance: you'll see general localized material loss where you'll see a pitted area with corrosion products inside them. So caustic gouging is typically categorized by localized metal loss that appear as grooves in boiler tube or locally thin areas under insulation deposits. Deposits may be filled with corroded depressants and mask the damage below. Probing suspected areas with a sharp instrument may be required. Localized gouging may result along the waterline where corrosiveness concentrates. In vertical tubes, this may appear as a circumferential groove. In horizontal or slope tubes, grooving may appear at the top of the tube or as longitudinal grooves on the opposite side of the tube. Corrosion of carbon steel: in high concentration caustic at elevated temperatures will be generalized but likely confined to a location of high temperature, that is next to heat tracing equipments. Prevention and mitigations. In steam generating equipment, caustic corrosion is best prevented through proper design. Damage can be minimized by reducing the amount of free caustic, by ensuring the adequate water flooding and water flow, by ensuring the proper burner management to minimize hotspot on the heater tubes, and by minimizing the ingress of alkaline producing salts into the condensers. In process equipment, caustic injection facilities should be designed to allow proper mixing and adequate dilution of caustic in order to avoid concentration of the caustic or hot metal surfaces. Carbon steel and stainless steel have serious corrosion problems in high strength caustic solutions at elevated temperatures. Alloy 400 and some other nickel based alloys exhibit much lower concentration rates. Inspection. Now generally it is going to be metal loss, a localized metal loss, so generally UT is going to be the better option for identifying thicknesses. You can also use some advanced UTs also. You can also use visual testing if the access is available. So general corrosion, UT, straight beam UT can use for measuring general loss of the metal. Localized corrosion, manual UT including UT scanning, automated UT, shear wave UT, PAUT, TOFD can be used to determine the extent of localized corrosion. RT can also be used within the limits of this technique, that is generally going to be a profile RT technique, but in most cases RT is not going to be that effective. Permanently mounted thickness monitoring sensors can be used. Caustic injection site should be examined and monitors as discussed in 570 and 574. So we have talked about this, where we have seen in API 570 there is a certain inspection criteria that you can apply for inspecting injection points. When internal access is not available, UT may be performed by a boroscope. VT may be performed by a boroscope, that is remote VT. And it looks something like this. So this is boiler tubes, and inside the boiler tubes you are seeing localized area where you can see thickness losses. In this case also, this is caustic gouging. At this location a large chunk of material has been removed and it is filled with some corrosion products. Okay, so this was all for caustic corrosion. In the next video we'll talk about something else, some other damage mechanisms.